Now that we've learned how to find missing angle measures of right triangles using inverse trig functions, some great word problems that involve using inverse trig functions are angle of elevation and angle of depression problems. If we have an observer standing at point P and looking up towards an object at point A, the angle from the horizontal from line PH up to the line of sight is called the angle of elevation. If we now have an observer at point P looking down towards an object at point B, the angle from the horizontal line PH down to the line of sight is called the angle of depression. Something you'll notice if I put both diagrams together, so say I have this diagram, and I have Mrs. Pettit standing down here, and a student standing up here. My line of sight up to the student would be the angle of elevation. However, the line of sight of the student looking down at me would be the angle of depression. If both those lines are horizontal, that means those lines are parallel. What do you notice about the angle of elevation that I have looking up at the student and the angle of depression that the student has looking down at me? You'll notice that the angle of depression is the same as the angle of elevation. This is because if two lines are parallel and cut by a transversal, in this case the line of sight, then alternate interior angles are congruent. If given the choice when working on an angle of elevation or angle of depression problem, I always draw my diagram in the same way, so that as I draw the bottom triangle, if I need to talk about the angle of elevation, it always goes in down here. And if I am talking about an angle of depression problem, that angle always goes in up there. So as I read this first problem, we're talking about a surveyor and is 130 feet from a tower. The angle of elevation to the top is 32 degrees. The surveyor's instrument is 4.75 feet above the ground, and it wants us to find the height of the tower. So the first thing I'll do is draw my diagram. Again, I always try and draw my diagram the same way if possible. So let's start picking out the pieces that we know. A surveyor, so I have somebody standing here on the ground. So this is the ground. And is 130 feet from a tower. So this is my tower. The person is 130 feet from the tower. The angle of elevation to the top, the angle of elevation is always from the horizontal to the line of sight. So that's where the 32 degrees goes. And the surveyor's instrument is 4.75 feet above the ground. It wants us to find the height of the tower. So the first thing I'm going to find is the height of the piece of the triangle that's missing, and then when I'm done, I'll add in that 4.75 feet to get me all the way to the ground. Again, we said the angle of elevation and angle of depression problems are going to deal with our trig functions. So I'm just going to put my SOHCAHTOA here to get started again. And relative to what I need for this problem, if this is the angle I'm going to work with, I'm looking for the height, which is the opposite, and I have the distance, which is the adjacent. Opposite and adjacent deal with tangent, so I have tangent of the angle equals opposite over adjacent. Remember, every trig function has three pieces: an angle and the relationship of the two sides. You always need two out of those three pieces, but if you have two, you can always find the third. So if I know the angle measure is 32 degrees, I can say the tangent of 32 is equal to the opposite over the adjacent. If I want to find the height between the observer's eye and the top of the tower, I'll multiply both sides by 130. That gives me 130 tangent of 32 equals the height. And when you plug that into your calculator, you'll find out the height of the tower from the from the eyes of the surveyor to the top of the tower is 81.23 feet. But to find the actual height of the tower, we need to add in that additional 4.75 feet to find the entire height of the tower is 85.98 feet. Now let's try an angle of depression problem. Like I said before, I always draw my diagram first, and the same diagram every time if I can. So if I'm dealing with an angle of elevation or angle of depression problem, I'll start with my right triangle. And as I start to read this problem, it says a plane is 3 miles above the ground. So here's the plane. The pilot sights the airport at an angle of depression of 15 degrees. So it's an angle of depression problem. So I'm going to draw in the other triangle that matches it on top. The airport that he's looking at is down here on the ground. The angle of depression is 15 degrees. And if I go back for a second, it said that the plane was 3 miles above the ground. What is the ground distance between the plane and the airport? Well, the ground distance would be this. But because those lines are parallel, if I want to transfer it up here, in that triangle, it would be that horizontal segment. So again, relative to my trig functions, so I have my SOHCAHTOA. In this particular problem, if I'm working with the angle of depression, I have opposite, and I'm looking for the adjacent. So again, opposite and adjacent deal with tangent. So tangent of my angle is equal to opposite over adjacent. So tangent of 15 is equal to 3 over d. I need to get that d out of the denominator, so I'll multiply both sides by d. I'll move up here just to give myself some more room. So I have d tangent 15 is equal to 3. And if I want d by itself, I'll divide by tangent 15, which remember is just a number. So I'll just plug that into my calculator. And when I divide 3 by the tangent of 15, I get 11.2 miles is the ground distance between the plane and the airport. Let's try another one that's just a little bit trickier. We have a satellite that's 25 miles above the Earth. So again, I'll draw in my triangle to get me started. And up here is the satellite. An observer notes an angle of depression of 40 degrees to the near side of a river and 37 degrees to the far side. So down here on the ground somewhere, we need to draw in our river. And what you'll notice is we're talking about the near side and the far side. So this is my river. And what's actually being created are two separate right triangles. Because we're talking about angle of depression, I'm going to draw in those triangles on the opposite side. That triangle will go from the far side of the river to the satellite, and this triangle will go from the near side of the river to the satellite. So what I know now is the satellite is 25 miles above the Earth. An angle of depression from that satellite to the near side of the river is 40 degrees. And the angle of depression to the far side of the river is 37 degrees. It wants to know how wide is the river. Well, if I can find the distance to the near side of the river, and I can find the distance to the far side of the river, if I subtract the near side from the far side, I'll end up with the width of the river. So I'm just going to do the same process twice. So if I start with the far side of the river, so working with this 37 degrees, I have opposite. I'm looking for adjacent. That trig function again is tangent. So I have tangent of 37 equals 25 over y. To get the y out of the denominator, I multiply both sides by y, and I have y tangent 37 equals 25. And to find the distance to the far side of the river, which is y, I'll just divide by tangent 37, which is just a number, and I find out the distance to the far side of the river to the nearest tenth is 33.2 miles. I now need to do the same thing to the near side of the river. So now I'll be working with the 40 degrees. And again, I have the opposite, and I'm looking for the adjacent. So again, tangent. So tangent this time of 40 degrees is equal to 25 over x. To get the x out of the denominator, I multiply both sides by x, and I have x tangent 40 equals 25. And to find the distance to the near side of the river, I will divide by tangent 40, which again, just a number. So x, in this case, the distance to the near side of the river is 29.8 miles. And to find the width of the river, I just need to subtract the two. So the width of the river will be 33.2 minus 29.8, and we'll find the width of the river is 3.4 miles. Now let's try an angle of elevation problem that allows us to use those inverse trig functions to find a missing angle measure. So again, just starting to read my problem. A submarine detects a battleship on the surface of the water at a diagonal distance of 500 meters. So I'm just going to draw in my right triangle to get started and start to identify where things are at. I have a submarine down here, and I have a battleship up here on the surface. It says the diagonal distance between the two is 500 meters. If the submarine is at a depth of 301 meters from the water's surface, determine the angle of elevation of the battleship. So just like we've been doing, we'll start with our angle measure. So here's the angle that we'll be working with. Just this time, that's what we'll be looking for. What do we have relative to that? We have the opposite, and we have the hypotenuse. The trig function that deals with opposite and the hypotenuse is sine. So we'll do sine of our angle is equal to opposite over hypotenuse. The angle is what we're looking for, so we'll leave that. Sine of x is equal to 301 over 500. To get rid of the trig function, we need to take the inverse trig function of both sides. And when I take the inverse trig function of the left-hand side, I'm left with just x. And when I take the inverse trig function of the right-hand side, remember it comes out front, the inverse sine of 301 over 500, if we plug that into our calculator, we'll find the angle of elevation to the battleship. When you plug that into the nearest degree, you should get 37 degrees.